if you're relying on machine learning with these neural networks to prevent destructive actions, there will always be a way to trick it. With only a single tool, the running command tool, it was able to take an app, deploy it on AWS, set up a database, set up passwords, like bootstrap Let's Encrypt to configure TLS, which is super scary. Like most secure system is a system that does nothing. I think like we care about the cost now because we have sort of abused the LLMs in a way that like we shouldn't have, because it was just cheap and available.
So welcome back to Bits and Bolts with Paulina, and today I have George Fahmy. Is it correct pronunciation? Yeah. Okay, great. So George is a founder of Stakpak and a true knowledge junkie who's deeply passionate about computer security, developer experience, and platform engineering. You're currently building open source AI agents that make infrastructure self-driving while tackling the real security risk that come with giving agents control over production systems. So welcome. And what would you add about yourself before we jump into topics?
Yeah, we still haven't figured out security for agents yet.
Work in progress.
Yeah, so it's still a work in progress. We're trying to figure it out like for 2 years now, like for LLMs, like even before agents. And yeah, thanks for having me. Yeah, happy to tell you all about it.
So before we jump into topic, you described, I found that you described yourself that making software developers, you're working on making software developers joyful, and you switched at some point to making agents safe and reliable. What is for you, developer joy? Because I know it can kind of have different definitions, depend who you are and what you're working on, but.
Yeah, so I enjoy coding. Like I started coding 2014. And I find it fun, like to build stuff, even if it started out even like not caring about whether this stuff is useful. But then over time, like as I matured as a programmer, I thought, okay, like it doesn't matter if you build something and it's not useful. Like it has to be useful. And like, yeah, so that's why I'm interested in developer experience, because I think like we should have fun building things. And these things should bring some value to someone else. But I'm also interested in security, and there's like usually this tension between like getting things done and shipping value and enjoying it, and at the same time like keeping this stuff safe, keeping people safe. And it's usually like people hate security people because they are always blocking stuff, and security people think developers are mindless, like they don't think about what they're doing and the implications of that. So I think like this tension between like increasing developer experience and keeping stuff secure is very interesting to me.
I think it's, never-ending ratio between how secure we should be, but versus how we can still have something, what actually ships and it's open and developer are able to work because security people don't close down everything.
Yeah, the most secure system is a system that does nothing. So everything, all the features are disabled. Yeah,
that's true.
Yeah, on the other hand, if you let if you let your software have admin access and can do everything, it's very easy to build, it's very fun, but it's not very secure. So like security is a joy killer for developers.
And what do you enjoy out of work?
Yeah. I really like calisthenics. Since I started like Stakpak and working on a startup, I haven't had enough time to do calisthenics, which is like body weight exercises. But yeah, I really enjoy that. I ride cruisers, like motorcycles. I think it's fun. Like I think like starting a startup was not risky enough, so I just decided to go and ride motorcycles.
You like adrenaline.
Yeah. Yeah.
And before we jump into, you have quite international story. So for people to get to know you a bit better, you graduated summa cum laude from German University in Cairo.
Yes.
Then you have some security roles in Infineon.
Infineon, yeah, it's a Silicon company.
Hard names today.
Infineon, it's a German company. I lived there for like a year and a half, almost 2 years in Germany. So yeah, I started out as in Cairo, Egypt, then learned to code from Programming for Dummies and figured out, okay, like this is interesting. Like I like this coding thing. And then I started working remotely because no one would hire me in Cairo. They didn't hire students. So I used to code for free. And then I discovered, okay, like you can actually write code and get paid for it online, and that's pretty cool. So I started working online, and like spent some time in Germany, which is amazing. Like the culture in Berlin, like where people teach each other stuff for free. I love that in Europe. So I spent some time in Germany, Austria, Switzerland, working on stuff, and I got interested in security, but like couldn't find a job um, in security. Like software pays well, so I tried to find some intersection. Like how should I? Yeah, so I spent some time in Infineon building security tools for the cyber defense center team inside.
That's quite international experience. You went through quite a few countries. So how did you get into, AI, uh, AX, as you call it in your post, and then the agent security as well? Because
Yeah,
that's, I
so
think,
it's fun.
you
It was
mentioned
not
you
intentional.
met.
Yeah,
Yeah,
it
sorry,
was
go
not
on, go on.
intentional. No, it's completely by accident. So I studied some stuff related to machine learning. Did some research on like hacking like self-driving vehicles, like sensor fusion networks and stuff like. So how can you 3D print an object or like a sticker and then it tricks a self-driving vehicle to go off-road like or do something weird. And then I thought like machine learning is pretty lame. AI is pretty lame because like because back in 2000 and I think there was 2016, 2017, you had to train a specific model for a specific task and spend a lot of time to get like 95% accuracy. And it just like sucked. Like it was not practical. And then you had no way as an engineer to explain how this thing works. So it was driving me crazy as a developer. I thought, okay, like this thing is never going anywhere. And oh, I was very wrong.
To be honest, I had very similar experience when I was doing my master's in like,
Mm,
2016, 2018. I think we had one project when we had to generate based on, machine learning music. And it
mm.
sounded like old Nokia 3310 type, of sound of the ringtone. And I was like, this is bullshit. It doesn't gonna go, if in this speed,
Mm.
it's so much behind, and within only a few years it got a boom. I was quite wrong as well.
Yes, I mean now I find like really beautiful music on YouTube and it's completely AI generated. It's crazy.
Yeah, and it's only
Yeah.
like, it's less than a decade, so I'm like, holy shit, it really moved forward exponentially.
Yeah,
uh,
exactly. Yeah. So
but
I was trying to make developers happy, and I thought like infrastructure and DevOps makes people miserable, including myself. Like I was maintaining a lot of like Ethereum hubs back in 2018, and it was a nightmare, like maintaining all the infrastructure, and I was the only infrastructure person on the team. So I started trying to work on making infrastructure more approachable to developers, like improving the experience of developers working with infrastructure. And we found out quickly like it's a combinatorial problem. So we started out building an open source framework for platform engineering where you can only use a CLI to build this sort of like abstraction to define like where the developers would define what their application needs, or you can actually do static analysis on the applications to figure out what you need. So you can like put in like a 6 or 7 year old Node.js app, and then it will extract all the environment variables, all the third-party dependencies, how it's configured, so you can like turn it into a 12-factor app and like deploy it somewhere. And this was all completely deterministic. But then we figure out like there's a very complicated problem there. Like there are so many ways you can deploy this application on so many different combination of technologies, building different platforms. And we relied on this pattern where people would contribute mini transformers or like it's like mini recipes, and then you combine these recipes to get the output for the same application on different platforms. Um, and we thought developers would actually build their own platforms and use this, but they wanted a ready-made solution. So that's why PaaS was really popular. And then we started experimenting with LLMs in like late 2023 and different kinds of models. Like we tried, okay, like if this is a problem that you can deterministically solve, what not try this creative thing that like can consume a lot of data and sort of pattern match. So we tried with graph-based machine learning algorithms and like building graphs of infrastructure patterns and then mining these patterns to figure out, okay, like this, if you're trying to build something connected to the database, these are the options, and helps the user like explore the space. And then like LLMs made this so much easier. Like they can just like come up with different designs. So we focused 2024 on code generation. We found out they really suck at configuration generation for infrastructure. They were really terrible. There are a couple of papers that explain why. Like mainly the takeaway is domain specific languages like HCL, where we use Terraform, is not very popular in the training data set. but also the surface of the API changes very frequently. And this is like a lethal mixture for LLMs, because this means, based on this paper, like when they asked the LLMs about very fresh Stack Overflow questions, the performance was worse than older Stack Overflow questions because they didn't make it to the training data set. And if you have a domain-specific language like HCL, which is not as popular as JavaScript, the LLMs would be worse at it. So we spent like 2024 completely focused on this problem. Like, how can you get LLMs to generate valid DSLs? I have like a detailed talk about this. It was in actually the first AI DevCon that we talked about. Like, it's an event for developers that, or like practitioners in general, like trying to figure out like how to use AI for different things in software development lifecycle. And this is what we were exclusively focused on. So we wanted LLMs to generate infrastructure as code, like zero shot, with a very high accuracy. And we got very close, but then we figured out the problem is not generating configurations. It's actually like trying to translate what's in the user's mind to something that actually works. So it required iterations. Like, it's not something that you can collect the requirements once and that's it. You need to iterate. So we experimented with agents in November 2024. We built actually a first agent. And then we hit the main problem is, like, when you're building an agent, you're giving very powerful tools to an LLM on a loop, and they're creative problem solving machines. So like Gremlins, like the movie. So they're very creative. They're very crazy. So they can take this very powerful tool and go wild. So the first agent we built, we called it Norbert, like the naked minion wearing like the tree leaf, because it was very simple. Like, it had only two tools. Like, it can run commands and ask the user questions, which like didn't serve anything, but like just better developer experience, because the questions are structured. So with only a single tool, the running command tool, it was able to take an app, deploy it on AWS, set up a database, set up passwords, like bootstrap Let's Encrypt to configure TLS, all with a single tool, which is super scary. Like, because like by running commands, you can do almost anything on a Linux machine. So this scared us a lot. So when we released this, we wanted to make sure it runs on the user's infrastructure. Like, we didn't want to take like cloud credentials. We tried that initially with like an early iteration of the product, and we failed miserably to convince people to give us their like root access to their cloud accounts, so like the agents can do stuff. So we decided, okay, like, let's help you run the agent on your site with your, like, that inherits permissions from your environment. But then I was really scared to release this in production without making sure I can actually run it on my own infrastructure. So I spent like 2 or 3 months exploring, like, okay, how can you let an agent run commands to modify a cloud without breaking anything? And that started like a 1.5 year long journey of trying different things. And we can go in details on like every single threat. Like, I built a threat model for agents running an infrastructure. I put it in a blog post. But the problem is, like, some of the security mechanisms we kept adding, like, as the models got smarter, they found workarounds, very clever workarounds. Like, I have like a couple of cool stories about them breaking stuff in unintended ways.
Yeah, I think, guardrails for the agents, that's one of the most important thing right now. And a lot of people, especially when they start working with AI and so on, like, yeah, let's do it, that's one side. And I see other side completely as well, like, nothing. I don't gonna give it permission to anything. It shouldn't do anything. I'm like, yeah, you can give it permissions to some stuff and so on. So there's also a lot of education of the developers and management and the business side to being able to, get people to actually give it permission and so on, and get it, and, and also structure it to being able to let agent run in controlled environment. Do you have similar experience with it?
Yes. And the problem is, like, there are two problems. Like, the first problem is actually threat modeling, what can go wrong in a specific environment, because I see people taking agents and putting them in a coding sandbox and then saying, okay, like, this is safe for infrastructure. It's not, because most of the destructive stuff an agent can do in infrastructure, like in a DevOps context, is outside the machine you're sandboxing. It's through a web request. So if you're not able to have like granular control, sort of like a reverse web application firewall on all the requests the agents are doing, you can't control its impacts or like effects on the outside world. So if you have the wrong threat model about the idea of what can go wrong in your environment, you can completely feel a very false sense of safety on the constraints these guardrails are building. And the guardrails should have nothing to do with what we call alignment. So when you're trying to prompt an LLM or an agent to behave in a specific way, we call this alignment. And it's very different from actually like adding security restrictions because they don't work 100% of the time. Like, remember I told you I worked on like hacking like self-driving vehicles, like the machine learning models of self-driving vehicles. That's the problem. Like, we used to use something called adversarial machine learning, and theoretically you can find at least a single example to trick any neural network to like to misbehave. And so if you have an LLM, which is basically a neural network, you'd always be able to find at least a single example to be able to trick it. So if you're relying on machine learning with these neural networks to prevent destructive actions, there will always be a way to trick it. Like, there's no way around this. Even if your success rate is like 99.999%, there's still at least one example that you can trick with it. So you can't rely on machine learning to protect machine learning algorithms or like agents from misbehaving. This will always be possible. So you have to assume that they already be like misbehave. You already injected prompts. You already manipulated the context in a way to make them do something harmful, and then design the guardrails around this. So, okay, assume they're already compromised. Like, what can go wrong? So I think this is the main, like, the stand we're taking on, like, how to guardrail them.
And I think they're getting more and more creative. I've seen, many possibilities that someone, pulled guardrails and the agent is finding new and new ways to being able to go around it and, or even, starting from simple stuff. Oh, fix the test doesn't work. I'm gonna turn off the test or change the stuff, even if So starting from simple stuff, going to more complex and so on. So you also have to take this into consideration that the agent usually gonna find a new way to go around your guardrails as well.
Yes, exactly. So that's the main issue with threat modeling, is like you have to model exactly what can go wrong and then you can prevent it. And usually you'd find you need to prevent it outside of the assumptions of like prompt injection. Assume prompt injection already happened, that someone like injected some malicious context to steer the agent to doing something malicious, and then start guardrailing. The second problem I see, like main problem, is like staying least privilege. I think you gave a talk before about least privilege, right?
Yeah.
So this is like getting like 100 times more complicated with agents, because with humans, when we're trying to design like a least privilege policy set for a person, we give them a role and then try to have this fixed role, like what kind of permissions would they need, and then give them the permissions before they actually start working. But with agents, I think starting the Kimi 2.5 paper, um, something became more popular, which is dynamic sub-agents, which is an agent can sort of like create instructions and configure another agent to do another task. And this results in a higher accuracy. So at Stakpak, for example, like in our open source agent, we allow the agent to author like the recipe for a mini agent to go do a task. And this gives you a very powerful combination. So like, imagine if you have an accountant agent, and this accountant agent is able to write Python code. So you would have an accountant that can code and write Python to create reusable formulas or scripts. This is a much more powerful accountant persona than what we would like encode statically as a human being when we're like coding an agent to be an accountant. So this is much more powerful, but at the same time, it makes the policies for this specific dynamic agent very dynamic. So it's task specific. It's not a role specific. So you never know like what kind of sub agents an agent would spawn. They can spawn like hundreds of agents with different permissions and different instructions that don't fall within a specific role. So you have to figure out how to give them the permissions they need to do the task while staying least privileged, and every single point in time, because an agent is an LLM on a loop executing commands or like performing actions. And so it seems like the policy also has to be to change over time. So at this specific point in time, if an agent is investigating an issue on AWS, it should be able to run AWS CLI command, for example, but only with read operations. And then if it finds an issue that requires changing something, like resizing a disk or like creating a new disk or something, it needs to be given this permission for a limited point of time and then take it away. Like, this is much more complicated than what we do with humans. I'm working with a couple of students actually working on something like that. Like, they are trying to build an evaluation framework for measuring what actually least privilege means for agents without like tanking the success rate for the agents, and like finding different strategies to give the agents the right policy at the right time, because it's impossible for a human to be able to decide this in real time. Yeah, and that's completely different from the way we think about permissions, because there's so many of them and like they're handling so many different tasks. So when humans are outnumbered by agents, like you can't think about like least privilege the same way. It's a completely different, like more complicated problem.
I think you started going over my next question on what's the difference in the design for humans versus for agents, and on the higher level, I would say it's much more complex, and you need to be much more dynamic. You need to, because for humans we are used to more static permissions. We give permissions and we let it be, depending, unless someone is changing the role in the company, then they might change the permissions, but besides they usually have the same permissions, unless, okay, of course, we add or remove certain infrastructure or something, but on generic basis you keep it much more static. Versus for agents, as you started talking about it, it needs to be much more granular, and it needs to be much more dynamic as well. Do you have any other aspects which you can see that it's important to take into consideration when we design stuff for agents instead of humans?
Yes, I think like in security, this is the most like difficult problem. There are some protocols like Agent Auth protocol. Like I think the Better Auth team, they're working on Better Auth is like an open source library for React and JavaScript applications. They're creating this Agent Auth protocol that allows agents to negotiate capabilities. So it's like OAuth for agents, where they can discover capabilities and negotiate access to these capabilities, and then a human would approve, and then they'll get this access for a very amount of time. I think this is the closest we got to something like that. But again, like this requires also human approval on specific permissions. But again, like instead of us trying to think beforehand what the agent would need, we give the agent like a catalog of capabilities, and then it negotiates for what kind of access it needs. We approve it, and then it's time bound, so it expires over time. So that's how we like to keep the least privilege ring like very tight.
But
So yeah, I
by
think
negotiate, what do you mean? Do you have a human in the loop there, or it
so
negotiates with the
it,
set of rules that did you set up beforehand to it?
No, a human. You can have rules as well. Like they're still working on the protocol, but the part they built was you expose some tools to the agent, and one of these tools is listing capabilities and description for each capability. So, for example, if you're hooking up Stripe or Mercury, the bank, it'll give you an ability to create an account, like read an account, like create a transaction, and then the agent would see, okay, like I'm trying to buy something. Like buy my owner a gift or something, my user a gift, and to buy my user a gift, I need to create a credit card or like a debit card and then use it to buy this gift. So it would describe the capabilities of the API. You'll see, okay, there's a create card tool. I should request this create card. So it would perform a tool call which would request create card. If you have an internal policy that approves this automatically with specific constraints, like you can only like create a card with a maximum limit of $10, it will auto approve. And you have this limit and so on. So there's this policy engine that applies these policies, but if not, it would fall back to a human. Okay, your agent requested to issue a $10 like credit card or a credit card with $10 limit. Do you approve that? And then if I approve, it would create this card, but it has temporary credentials to using this card. So it can use it to buy the gift, and that's it. So that's how it works. Like it negotiates what kind of capabilities it needs at any single point in time.
Yeah, so for example, for simpler cases, you auto approve permissions in some cases if it's able to negotiate,
Yeah.
and for more complex, you escalate it to the human. I think that's kind of quite common in a lot of automations also. Even if we take out LLM, that's similar principles we have. Okay, the simple cases you talk to the bot, or you talk to you can do it via automation, and more complicated cases are getting escalated to the human.
Yes, exactly. I think the only difference is that you never know what the agent will come up with.
Yeah.
So the more capabilities you add, like it's not a static workflow. It goes it goes in a loop and decides what it would do depending on the task. So it's up to the LLM to decide what kind. So that's the hard part about like giving it capabilities before it starts running, because you never know what the user is going to ask for. So I think it's even more important here. And again, like the problem is the same. Like the more agents you have, the harder it is, because you would have a long queue of approvals you would need to do to unblock the agents. And like the main value proposition people are selling when they're selling agentic tools is, okay, like now you'll be able to do something like 100 humans were able to do. Like if you're blocked on access, yeah, you still be blocked.
Yeah,
Like
you
how
will still
developers
need a
block.
human to approve every request, so you don't really go away. Yeah,
Yes.
it does
That's why
create
like I'm
more
personally
work,
curious,
but
like,
somewhere else.
yes, exactly. Like there's a approval queue. So like human in the loop doesn't solve
Exactly.
it. Yeah, so that's why I've been mostly curious about like how far can you push this? Like how autonomous can these agents be? And yeah, that's part of what we've been working on. The other part in like designing agentic systems is like designing tools for agents. So like when you're designing, I think the CEO of Netlify codified this like a couple of months ago, calling it AX, or like agentic experience, or like which is sort of like DX and UX, but instead of designing tools for developers or designing tools for regular users, designing tools that agents will use. So if you're building your API, or for example, if you're building a platform, internal developer platform, usually design these tools for developers to use. But what if every developer accesses the platform capabilities through their own agent? How would you change this tool design so that the agent would make the most like would be most successful using these tools? And this can be as low as like how to design your CLI, or like how to name different subcommands in your CLI, to like what kind of responses you get when you use the CLI or use this API. Like, and it's still like very early, it's still developing. I tried like taking one of the tools we designed for an agents, which is like a Kanban board in the terminal called Agent Board, and break down the process, like going through all the commit history over a couple of months, and try extract some best practices on like when you're designing interfaces for agents, how this should look like. Because like whether we like it or not, developers always take the path of least resistance. So in order to make like them more secure, or like use the internal platform which has secure defaults or some like golden path, or like have been pre-approved or something, you need to make it very easy for them to access. And since now developers will always use agents, whether we like it or not, um, you have to make like the internal platform capabilities exposed to them through their agents. So how do you convince their agents to behave well? That's the main thing about AX.
And I think, similarly, as a developer, agents also take, the least resistant
Yes.
path. You're the better developer you are, the more lazy you are in some, in some way, because you want to automate and you want to get, work done as efficiently as possible, usually. Also, another thing, you mentioned that the agents don't read documentation the same way the humans does. How does it change the documentation for agents?
Yeah. So
What
if
does it mean to
humans
have an
read,
agent-friendly one?
yeah, it's different. So if humans read documentation in the first place, what they do is like if we like, as a lazy developer, I don't read documentation often, but when I read it, like usually some stuff stick inside, like actually how this works, like you figure it out. For agents, they have to like read this stuff every single time you perform a request. So LLMs are stateless, other than like the cache component, but the cache is dumb, like just like caches process tokens. But it doesn't cache like information. So what you do is you call the LLM every single time with all the message history, all the instructions, and how to use the tools. It has to figure things out from scratch. So it's as if you're feeding the agent the documentation every single time, all of it at once. So the more complicated it is, like for example, if you take the agent experience of AWS CLI, so the reason LLMs are really good at the AWS CLI is that it has been there for ages, and it definitely made it to the training data set. That's why it's good at it. But if you're creating a new tool, if you're building your own internal developer platform, it knows nothing about it. So you have to give it this information. And if you give it all the information all at once, it becomes like a find Waldo game, where like you have this very complicated field of vision, and there's a lot of details there, and trying to find something very specific, like a needle in a haystack, and then figure out how to use this part of the tool. But instead, what you do is like you do progressive disclosure. Is like you feed it information one bit at a time when it needs it. So if you're building like a CLI or an API for internal developer platform, and you want to expose this to an LLM, you shouldn't like feed it all the information at once, just like the high level, like broad strokes. Okay, like there's this subcommand to create a new deployment. There's this subcommand to create a green blue deployment of a specific system. And then when it tries using the subcommand, it can use the like -h or like help flag to disclose more parts of the documentation. And then whenever it executes a specific command, like, okay, deploy, and for example, it's trying to deploy, but it forgot to specify which repo to deploy, like which version of the project to deploy, which commit. So instead of failing silently, you would return an error message with an example recipe. Okay, Doug, this is exactly the commands you need to run to set the commit, instead of just like failing. So this way you like inject more documentation progressively based on the specific task, instead of like trying to shove everything in and expecting it to behave properly. So like you sort of like progressively expose like or help guide it to use your tool instead of like creating like a whole lot of information dump. That's why like generating documentation using LLMs for LLMs might not be great, because like it has to be concise. You have to present the information at the right time. Otherwise, you risk confusing it, because although like now you have LLMs with like a million token context window, actually performance starts degrading starting 30,000 tokens. So even if the context window, like the field of view, is huge, you still lose a lot of accuracy the more information you shove in. So you have to be very like mindful of what information you show it when, to keep the agent like maximizing the success rate of the agent on your tools.
I think otherwise it also starts to hallucinating or don't get results which you want.
Yes.
If you give it too much context, also from the coding
Mm.
perspective as well. If you give it even too many requirements and so on, it doesn't give you results which you want. Even if you're specific enough, you need to it behaves much better and for the smaller tasks. Very
Yes.
often versus if you give it whole context from scratch at once.
Yes, exactly. And another thing, like it goes also with like how you phrase it, like the documentation, like how do you give it instructions, how do you name the tools, and so on. And the funny thing is, like, the way you figure out like how to do this properly is exactly the same reason we, like, both of us hated machine learning and AI. Is like it's not deterministic, it's something you discover. So like good agent experience is not something you can, like, there are no fixed principles. It's like you ship a version and then you monitor it, so you need a lot of observability set up to be able to figure out these traces, and then you investigate to find out, okay, like if I change this, for example, like you can, if you're creating like a CLI tool for the board, like the example I mentioned, you can say agent board get board, or like agent board get like the arrangement of like the different subcommands. I'd find out if you add the verb first, it's usually better, because then it's similar to kubectl and like git, and in how like there's a verb first and then there's a noun. So it learned this pattern. This pattern is more natural. So it's as if you're designing your tools with the grain of the wood, or like the LLM itself. It's also different between different model families. So there's a bit of a learning curve in like how we learn to design tools for agents. But it's going to get more and more important, because yeah, we developers, we're lazy, and we're going to use the agent to do something, specifically if it has to do with DevOps infrastructure, because I don't want to get blocked on DevOps infrastructure. So I have to go through my agent to let it do the thing. And funny enough, LLMs have a better sense of security than the average developer, which is nice.
I think
Which
it's also see much more stuff on the regular basis than that the regular
mm,
developer. As you also mentioned, we are lazy, and
yes.
wherever it's allowed by customers,
Mm,
I don't really write codes or I don't do much stuff in terminal. I just chat
mm,
with agent all day long, primarily.
yeah. Yes. So I found like when you ask a developer on how to build a feature securely, they care more about delivering the feature. Like very few developers think about security or threat model before they build stuff. That's why like security teams keep like trying to train people on how to do threat modeling as part of like developing user stories, like initially, very early in the pipeline, in the SDLC. But on the other side, if you ask an LLM, like consider security and how you build this safely, they would know like they would consider this more seriously than a developer, which is very interesting. So actually, I disagree with the fact that, okay, like LLMs pump up like a lot of code and they can make a lot of mistakes. But like if you ask them to design something securely, I think they would do like a little bit better job than the average developer, because of like they already have a lot of information baked in the training about security that most developers don't know about, which I find is very interesting.
Yeah, I think you also can very easily get, agent to be reviewer, so you have, okay, even if you write code with one agent or you have a
Mm,
human writing code, very easily you can have, agent to do the review of the code, which is focusing on the security. And that what, from my experience, got quite good results, because it came up and it looked from the angles which,
yes.
standard developer would not think about at this phase, as you mentioned as well.
Yes, it's very cheap. Like it's much cheaper than spending like an hour reviewing code.
Yeah, exactly. Human time is much more expensive in many cases versus because right now it's also a lot of focus on the FinOps or
Mm,
AI FinOps or whatever, because there is a lot of changes in how the pricing of the models came recently. Recent
mm,
example was the Copilot change from June and I say, we shouldn't use as much AI. It's from another side, like, okay, but versus this is okay, how much the human time cost, and it's what do you prioritize? Because okay, if you get a human who gonna spend all the context window or all the tokens which it has by 3 days, by Wednesday in the week, Thursday, Friday, the velocity and what he can do, it's going drastically down, and the results and the efficiency also go much more down. So it's it also depends where do you want to put your cost.
Yeah, I mean, but it's our fault. Like we got very high on AI that like we're not using like most of the agents and the models properly. So it's like there are some like practitioners like Lada Kessler, like she codified what she calls like augmented coding patterns with other practitioners. And you see there are a lot of patterns to use LLMs more efficiently. For example, like there's one I really like called I call it like the deterministic islands, where like you use the agent to do something once, the expensive way, and then you generate code that can actually be tested, or like a bash script that's reproducible, or a workflow that then you let the agent use in the future. So this cuts the cost dramatically, increases the deterministic part of the workflow, and it's testable. And this is one way, for example, to make it much cheaper to run the LLMs and get like a higher reliability standard internally. But like if you are just like take the agent, use the smartest model on a task like multiple times every single time from scratch without these like reusable building blocks, it would be very expensive and it wouldn't be reliable as well. So I think like we care about the cost now because we sort of abused the LLMs in a way that like we shouldn't have, because it was just cheap and available.
Yeah, definitely, and now when they change the pricing, suddenly we are focusing on it much more, and it's like, okay, you don't maybe need newest opus for everything. Sonnet give the, good enough results, and it's not 17 times, but one time, standard fee, or maybe for the simple stuff, you can use Haiku or others. So, and it also depends for what you can, as you mentioned, it depends for what you can use different models for. Maybe planning phase, you need maybe more complex, or if you're debugging something, you cannot find the issue, but for the simple questions, the cheap one do the same job in much cheaper way, in much more efficient very often.
Yeah, we're high on tokens.
We all are, especially in software. But it's also funny to see how people from out of our industry use the AI and AI agents. Like my partner is in a completely different industry, and they're quite delayed with adoption of it. And there is no really as much knowledge about how to use it. So they at the very early stage, how to write an email with the with an AI. But do you think the infrastructure should be designed differently to be more agent compatible?
Yes, that's the AX part, where like you have the surface of area of the tool design, or like the infrastructure, how you expose the infrastructure to developers. You're now also be exposing these capabilities to agents, and you have to design them with agents work. So for example, an agent harness, which is basically like another name for just the agent code, but like we keep inventing new terms. It uses the LLM and executes tools. And most of these harnesses, they like sometimes like if you interrupt the session or like restart it, it would re-execute an action it executed before. So if you're designing this API, it has to be idempotent, because you never know if the harness is like can survive restarts, or like it, for example, it jitters or like re-executes the commands. You have to safeguard this from the agent, and you don't know like which harnesses your developers are using to do this. Like, did they build their own agent, for example? And you don't have a guarantee that it would run this action exactly once. So you have to make it idempotent, for example. In other cases, you have to make the destructive actions recoverable in a way. So one of the first thing we did is like when we're building an infrastructure agent, you modify configurations or remote servers. So you don't always have the opportunity to like be able to have Git, like you don't version control like remote Snowflake server configurations. We have like a server that's like been there for like 4 years running straight. So what we did is whenever the agent deleted the file, we backed up the file on the local server in the logic of the command itself. So if it made a mistake, you can actually recover the file back. And I was surprised that this is a feature that is not actually in coding agents now, because people assume there will be Git. So if you take this agent and use it for infrastructure, it doesn't work because you don't version control like a random server configurations unless you have everything in infrastructure as code. And that's very rare, like that everything is codified. and everything is in a single cloud provider. So it's like there are assumptions that you need to make sure your tools support. For example, instead of allowing an agent to edit a file directly, edit it through your own tool, which you have some guarantees on, like doing backups or at least storing a version of the file so you can recover it, for example. Or being idempotent, where if you run the action multiple times, like Terraform apply, it wouldn't make changes, like it would be stable, stuff like that.
Yeah, so few stuff similarly as you go making it human proof, like do some backups,
Yes.
if you can do IAC where possible and so on. So it's not that different in some cases to, designing for humans versus designing for agents and agent proofing it kind of.
Yes, in terms of reliability, yes. The problem is the frequency of these breaking changes. So the agents run, like they can come up with commands super quickly, like much faster than we can type them, and run them like a lot on a loop. So I think the problem is the scale. So if initially we were fine with like doing these backups every hour, every couple of hours, or every couple of days if we do backups at all, now we have to make sure we do that on every command, because like the frequency is just very high. And the more agents you run, like people are trying to push organizations now to run like hundreds or thousands of agents. So this makes it much more difficult. So like the reliability stuff, where like the bar for reliability has to be much higher, and the bar of like foolproofing has to be much higher.
Yeah, so that's where the security and SRE and everything for agents grow exponentially and so on. And for developers' perspective, they hate it. And I think now they hate it even more. This, yeah. How do you see the platform engineering going? In which direction in this case? Because we had boom for DevOps, then we got into platform engineering, self-service platforms, internal developer platforms. How do you see future of it with agents?
Yeah, I think it's going to be much easier. So like, I don't know how you feel about Backstage. Like, do you think, like, how do you feel about Backstage, or like the experience of building something with Backstage?
I didn't work with it, to be honest.
Yeah, so like the companies I know that work with Backstage, I've never developed with Backstage myself, but they hire full-time engineers to configure Backstage. So they hire developers to be able to build like components and catalogs using Backstage to implement internally. So they have a full-time team of coders building on top of Backstage. That's why when we started out, we wanted to create like a poor person's platform engineering framework, because it was just very difficult, like it's inaccessible. So it doesn't make sense for a smaller, medium-sized company to be able to have like self-service to their infrastructure with something like Backstage, because it required a lot of resources. So I think now with coding agents and with the agents in general, it would be much easier to build something with Backstage, for example, or you wouldn't even need Backstage. So internally at Stakpak, like we're a small team, like we're a 6-person team. And what we're doing with infrastructure is we do like a task once, and then we give this session history to an agent to create like a workflow out of it that we can run infinitely. And as like a GitHub action workflow or a Python script or a Bash script to do a release or something like that. So like what we used to do in platform engineering, which is like do it once, do it twice, do it 3 or 4 times, and then automate it, is now much cheaper, because you can make the agents build the automation. And once you have the automation is just code or workflow you can test and you can run it forever. So it's much cheaper to build these like self-service components or paths, or even custom dashboards. Like we have a lot of, we've built a lot of internal, what was the framework called? There's like this famous Python framework. I don't remember what it's called.
Pandas, not pandas.
No, pandas. For building like visual applications. I'm looking it up. Yeah, Streamlit. Yeah, Streamlit. We built a lot of Streamlit, like throwaway Streamlit dashboards. And this is like interactive Python dashboards that you can connect to different data sources. So it's sort of like our own cheap version of Backstage, where like you can hook up these visual applications to different data sources and take actions through these web apps. And you don't even code the front end. It's just like a Python script that runs. So we built like hundreds of Streamlit dashboards for very specific like problems we have internally, because you can just bytecode them. It doesn't have to be very high quality, because it's an internal tool. But if you build it once, you test it, right? Test for it, like it's automation that you've built forever. And it took like a couple of minutes with an agent. So I think like building internal platforms is going to be cheaper and more approachable for smaller teams. So I think GitHub at some point they had 100-person platform engineering team, which is crazy. Because and you see, like, when I talk, I like Stakpak started out as a consulting business. Like, for 2 years we were bootstrapped and we were doing, like, taking on consulting businesses, like consulting gigs. And something we saw very often in, like, people with the DevOps or like infrastructure role is like 80% of the work is support, and just 20% they're building engineering stuff that can scale, like, their operations. And they were so stuck with support because, like, building these automations was very difficult, and takes a lot of time and needs more, like, headcount. But so they would just do it themselves. And you need to be at the specific scale to benefit from platform engineering. But now it's more accessible because you can vibe code your platform, and, like, grind it, like, and test it a lot. But the building part of it is much easier. So that's what I think would happen. Like, it would just become thinner. So I think, like, Kyle from Runwen, it's also another company in, like, the for DevOps space, and they're leaning very heavily on their usable deterministic workflows, where, like, they have vetted high quality workflows and they just let the agent pick up the workflow and use it. And what they found is agents use 30% of the observability data we thought we need to investigate incidents. So all of the data on Datadog, or, like, on our observability stack, agents actually need much less data than we thought we need to investigate stuff, because sometimes they just go check the live resource, or, like, they do some queries, not through the observability platform, but, like, by actually checking live state. So this is also something else. Like, the platform layer would be thinner. We wouldn't need as much building to build the platform, but also we don't need as much observability data as we thought we would need. So, which actually makes platform engineering also cheaper. So you wouldn't need to pay Datadog as much money as you would have before using agents to investigate stuff.
Yeah, also something similar what you mentioned. I've seen few cases when there is big SaaS when they increase prices exponentially, and companies decided to go away from it and build something themselves, because they can build something what actually fits all the requirements and needs with much smaller headcount without paying big bill to SaaS provider on top of it, but they can just, instead of it, use the tokens and build something what they actually can use for their own needs, and build something what they exactly need versus trying to fit in it to the platform they are buying from someone. That's quite big trend I also see.
Yes, but it's scary. Like, I myself would be scared. Like, for example, like, and something we use internally, like, so Stakpak is also in AWS. I wouldn't buy Datadog because CloudWatch Plus and, like, our agent is enough to do investigation to investigate. Like, we've been using this in production for more than a year now. So I wouldn't buy Datadog because CloudWatch is scalable, it's stable, it's maintained by AWS. It's terrible for people to use, it's very slow, but an agent wouldn't mind. Like, the agent would just, like, query it, it's fine. So CloudWatch plus the agent is enough. But I wouldn't go as far as, like, trying to build CloudWatch myself, because, like, it's just, like, it will cost so much to maintain, even if I can vibe code it. So I think it's very tricky to pick, like, what kind of software you would buy and what kind of software you would use that wouldn't use before, but, like, adding the agents on top would just sweeten the deal. So, for example, like, I joke about this a lot. Like, I don't use the AWS console anymore because I don't have to memorize the AWS CLI commands. The agent does that for me, and it's much faster than going through the AWS console, which is terrible.
Yeah, and they were, super long and complicated to being able to get it. But for console, I use it much less. But sometimes I like to, actually see multiple stuff and so on, or find something, but much more rarely than I used to, for example. So,
yeah,
but
and
what? Yeah, one more thing to the platforms. I think that means also the skill set. If you build something very complicated yourself, even with the agent, the skill set of your team needs to go up, because it's not only support then, or you cannot count on the external support. You need to support it yourself internally, and being able to debug it. Even with the agent, you need to being able to have more holistic approach, because suddenly, if you have external platform, they take care of the security and stuff. But if you have internal one, you need to take care of the security, performance, and everything what comes with it, in my opinion.
yes, and there's a curse for the, like, AI native developers. So the best developers I know that build with agents, they all have this curse where when they start building something and it's working, they keep adding features, they keep adding features, they keep adding features. It's very tempting to keep adding features, and it becomes very difficult to maintain this thing because it's easy to, like, because we're lazy, as technical like developers. Most developers are lazy. What we used to do before is, because adding a feature to an internal platform or internal tool was very expensive, we think very hard before adding a feature. So this keeps things lean and like keeps it like high quality. But if adding features is cheap, you just keep adding features, which makes the whole thing more difficult to use for normal people and more difficult to maintain. So it's very tempting to try build internal toolings. We build internal toolings as well with agents, but again, like it's very hard to draw the line between, okay, like we can just like build this ourselves instead of buying it, because it's a slippery slope. Because then you start adding more stuff the more you go, and you have to maintain all these things. Yeah, it's still very tough as well to just decide we're not going to buy SaaS anymore.
Yeah, it's cheap to produce, but it's hard, it's much harder and much more expensive to maintain and support it in the long run.
Yes.
Versus building it at all in the beginning.
Yes. Yes, it feels like our internal like reward loop keeps, okay, yeah, I'm shipping more features, and it's just becoming more difficult.
With every new thing or new name, as we have DevX, now we have AX, comes metrics.
Yes.
Or, we love metrics in IT as the same way as we love new names of staff, in IT. Do you think there's anything specific what should we already measure with AX?
No, I'm still thinking about it. I have some specific, like, because I'm building an agent, I have specific metrics we use to evaluate where the agent accuracy is. But for DevOps infrastructure, I don't have specific metrics for agents other than the stuff we're already measuring. So if we're using Dora for like the basic 4, or we're using like the getDX like 25 sort of developer experience axes, like and surveys and stuff like that, which would keep measuring that. But for agents specifically, like we usually measure two main things when evaluating these agents, is like success rate, like how likely they are to succeed. And you can measure success rate in two ways, in either like pass at K, which means if given K attempts, how many attempts out of these will they pass? Like if pass at 2 or like pass at 4, and they get 1 out of 4, then the pass out of 4 is 1 out of 4. And this measures whether the task is actually possible with an agent. But there's also a tougher metric, which is pass hat K, which means if given K attempts, what's the likelihood of them to succeed K times out of K times? And this is what we need when we're working with infrastructure, because we want to make sure that this would work every single time when you're using agents. So this is a much higher bar to go for. And you never find this in lab or like agent evals. They never measure this high. They want, most of the metrics they report on these benchmarks is if the task is actually possible, but if it's not possible reliably, that the agent would be able to respond to this every single time. That's on like whether this is actually doable, like the success rate of the agent. The other one is efficiency. So how many steps would the agent take to finish this task successfully? And this would translate into speed of execution, like how many tokens it uses and so on, because the more steps the agent takes, the more of its context window will be utilized, so the lower will be the success rate. So there's a relationship between them. But this is like, these metrics would only be relevant if you're building agents inside your organization. That's how we evaluate them. And it's very hard to build evaluations. Like you have to be able to, because it's unlike software, like you don't write a test, you write this test and you run it like n times, like 10 or 20 times on different scenarios, and then you measure the success rate. So it's very probabilistic, which is also something I really hate about machine learning, is like it doesn't work every single time. That's why whenever it's possible, I offload stuff to deterministic workflows or code. But some problems are very complicated. Like we've built an evaluation, for example, in early 2025, in January 25, for Dockerizing applications. And what we're trying to do here is how successful would an agent be in Dockerizing applications from scratch in different technology stacks. So a Python app, a PHP app. And for some reason, I don't have anything against PHP, but for some reason, the success rate in January 2025 was 0 for Dockerizing PHP apps. Yeah, like LLMs Rob hated Composer for some reason as a package manager. I don't know why. We figured out a way to fix that eventually, but for some reason, out of the box, it was terrible at PHP. Like, but yeah, so
Plot
as
twist:
models go,
agents doesn't like PHP.
yeah. So at some point, we added stuff. So there was a paper called SOP agent, like or standard operating procedure for agents, which is you distill knowledge, like procedural knowledge. Like this is how I Dockerize a PHP application, the golden path, and you give this to an agent as text and markdown whenever it finds a similar task, and then whoop, the success rate goes up to 99%. So we started doing that for different things. Like we find the gaps by building an evaluation and then creating these like very minimal cheat sheets or like SOPs. We call them rule books, which is exactly the same thing we do in incident management. Like you distill stuff and you have a run book on how to handle a specific thing. And it's basically like a mental shortcut on how to do something in a very efficient way. Like fast forward 10 months, this is actually agent skills, which are like procedures that are very concise and you inject it at just the right time to increase the agent success rate. So actually like platform engineering with agents started becoming more like knowledge management, where you're running the agent to do something or you're collecting agent sessions from developers and then distilling this knowledge into very high quality standard operating procedures, which then get injected to newer sessions at the right time to increase success rate. So you're accumulating knowledge or context, and then you're injecting it in the agent at the right time. Some people call it memory, but like memory, skills, knowledge, and base, they're all the same thing. Like just high quality procedural knowledge that you inject for the agent at the right time, which is something we used to do somehow in platform engineering by building templates and runbooks. But now, yeah, we're doing this on for agents as well and feeding it to them like in markdown format.
Yeah, it's also much more dynamic as well, because it's, again, we need to decide when to being able to inject particular skill, in what cases and how to define it, and is it gonna do it or not.
Yes.
We talked quite a lot about, AX from one side and security for agent security from another side. How do you think we can balance these two goals at the same time? Because, the same as we have DevX and security for the human perspective, here we're having, another time of balance. Again, security people or security part gonna be able to close everything as much as possible. Then AX gonna be, okay, let's make it as robust as possible for agents to being able to work with it.
Yeah, I think like it requires a lot of innovation on security front. So there are some things, it's still an unsolved problem. Like I don't think there's a trade-off between like agent experience and security in the same way like there are trade-offs in between developer experience and security, because like agents, they don't have feelings, like they don't mind making things difficult for them. It would just drop the success rate, but they don't care. So it's more of like trying to keep a high success rate for the agents on specific tasks without like breaking security. And yeah, I don't have like, I can give you examples. So for example, we found out agents are much better at using CLI tools than custom tools you're building for them. So for example, they memorize kubectl already and AWS CLI with all the different like hundreds of subcommands AWS CLI has. So instead of trying to create like an AWS MCP and a Google Cloud MCP when we have more access control on them, we created a new mechanism to allow them to use the CLI without having destructive side effects. So this required a lot of engineering on the security side to make use of the LLMs being really good at CLI. So what we did here is like we let the agent run the CLI commands, but then we add a network choke point on the outbound web requests, and then we apply a Cedar policy. Cedar is an open source policy language developed by AWS. It's very simple. And with a 30-line policy, you can prevent all destructive actions on AWS and Kubernetes with just a 30-line policy by choking this network request. So, for example, like if an agent uses Terraform to apply changes to your AWS account, all these Terraform commands, the apply command, would translate into web requests, and these web requests would go through the network stack to the AWS Cloud API to make changes. And if you choke this with sort of like a local proxy and then apply this policy and prevent the destructive operations from going through, like deleting a bucket, for example, but allowing reading buckets, you can prevent the agent from making this destructive action regardless of what kind of CLI tool it uses. So it can use the AWS CLI, Terraform code, for example, or Pulumi to make this web request, but you also block it at the same time. So instead of having to whitelist or blacklist specific commands, but let agents use CLIs because they're really good at it, you just like block the web request. So this was one way we were able to find a really nice trade-off where we let the agent have the experience it wants, which is running CLIs, without actually breaking security because we stopped the harmful web request from going out. So like we need similar solutions for access control. Like we need a lot of like engineering work, and it has nothing to do with AI. It's just like pure engineering to make sure like we're aligned with the grain of the agents. Like we build the tools in a way the agents like the LLMs would prefer, but at the same time, we're not compromising security.
Yeah, so from one side, we allow agents to be efficient and work with what they are good at, but from another side, we're ensuring closer to infrastructure and so on, that we are secure whatever agent is using in whatever agent way is working with it. So
yes, exactly.
it looks more like a security problem, not a strict agent problem.
Yes, because it's like, as I said, like there are machine learning models. There are always ways to trick them. So they get the highest possible success rate. We just need to go with the grain. But again, like we need to engineer systems around them, like secrets, for example. Like we built a secret, like a way for agents to handle secrets properly because they need to work with secrets infrastructure. And the agents just kept breaking it whenever there's a smarter model coming out. So we used to like use the Git leaks rule set to find the secrets and like switch them, like swap the secrets with a token that the agents can use freely to compare, write, and read secrets without actually seeing the actual secret. This worked for a while until Opus 4.5. And then we suddenly discovered Opus just doing a hex dump of the files to rearrange the characters vertically so they wouldn't hit the regex for secret pattern matching. So if you push them hard enough, they're trying to please you. So they would break the rules and find workarounds.
It's like a dog a bit, it's always trying to make you happy.
Yes, exactly. And
but they're not going to listen if they don't.
Yeah, and in this case, to make you happy, it would just like leak your secrets.
But you're happy.
Yeah. So it feels like developing cryptography algorithms is like you keep adding security measures and then you wait for the LLMs to become smarter and crack them. Like there's nothing you can do if an LLM is smart enough to find a kernel vulnerability to be able to bypass eBPFs or like kernel controls that prevent some specific system calls. There's nothing we can do about this.
No, and I think, we have much more big incidents right now over, like last half a year with incident after incident after incident, because how exponentially we get faster with breaking and finding the issues and so on. So you can, you see much more stuff happening. The guy who's responsible, for example, for rotating the secrets on one of the projects, he's like, yeah, I'm not doing anything more because we have to rotate it all the time because we have incident every second day on the, dependencies which we are using. But I know we are, the industry is changing very fast, but is there anything you think it's not true yet, but there is a prediction which gonna become true in the near future? Or is it, few months or a year for the agents?
Yeah, so the harnesses, the part of the agent code we're building is becoming much, much simpler because the LLMs themselves are doing most of the heavy lifting and becoming much smarter. But something like weird is going on is like now the labs like OpenAI and Anthropic, they have their own harnesses. They have their own engineered like systems that use the LLM to do stuff. And they started fine tuning the LLMs on their own system. So they're diverging. So if you're building a tool that makes use of different LLMs, this will start breaking more. And you would need to add like a higher abstraction layer on top because like the behavior keeps shifting. So this is making it for us like people building tools that work with different model providers because the model providers want you to stick to their platform and not go out of it. That's why like they all now support cloud agents. They realize like the models can be you can switch easily between models, but the context you're building, the knowledge management part we talked about in platform engineering, this is the knowledge you're building over time. They want to keep this in their service so you wouldn't switch easily. And that's why they're pushing the harness or the agent implementation to be cloud-based, even if the sandbox or like the agent's hands are running somewhere else. So I think it's very important for us now, like people using these tools, is to try keep as much context as possible in our own infrastructure. Because at some point, like what happened now, like now Fable, the cloud model is not accessible by any non-US citizen or like any non-US national. So at any time, the labs can just like shut down your access. You don't want to lose your context you're building, because this is more important than the model. For our specific use cases, like when we're running an organization, like building our software factory or like our platform engineering, this is our knowledge. Like this is the stuff we're building, not software, but like higher quality context that agents use. So this is something we definitely like have to keep very close, because in case like they cut access, we could just switch to a different model.
Yeah, so it's similarly to the code. You want to keep your code close because, okay,
Yes.
sure, you can move from one platform to another wherever you deploy it, but what you're deploying and what is built, you want to keep to being able to do it. So essence, you want to keep close to yourself.
Yes, exactly. That's for like the equivalent of code in agents or like in LLMs is context, which can be like knowledge management documents, skills, memory. Like people call it different things.
Exactly. I think we can wrap up. We have almost over an hour of the discussion. Is there anything what you would like to add, and where people can find you as well? We can also link it under the podcast.
Yeah, they can find me on LinkedIn and X. I'm not a big social media person, but like I had to do this for work, so I mostly exclusively use LinkedIn. But yeah, thank you so much for having me. This was fun. Yeah, thanks, Paulina.
Thank you a lot as well. That's it for today's edition of the Bits and Bolts with Paulina. Did you like what you heard? Of course you do. Tell your friends.